In today's video, we are going to be discussing dietary reference intakes. So after today's video, you will be able to define and describe a whole list of acronyms that help people know how much of a nutrient they should consume. These include DRI, or Dietary Reference Intake, RDA, or Recommended Dietary Allowances, AI, or Adequate Intake, UL, Upper Limit, EER, Estimated Energy Requirements, and AMDR, Acceptable Macronutrient Distribution Ranges. So let's start by putting the term DRI, or Dietary Reference Intake, into perspective. The DRI is an umbrella term for different categories of values that describe how much of a nutrient someone should consume. All those acronyms we just went through are part of the DRI. Now, the DRI are recommendations that apply to healthy people only, and the DRIs recommend amounts of essential nutrients that are safe and needed for health. Now, the different categories or levels in the DRIs, like I said, are the acronyms we just went over, and so let's go through each one in a little more detail. First, let's talk about the RDA or AI. These are values that provide the recommended intake amounts for healthy individuals. So the RDA, or Recommended Dietary Allowance, is derived from solid experimental evidence and research, and it's very reliable information. The AI, or Adequate Intake, is based on available scientific evidence, but also a little educated guesswork. When we don't have enough evidence, or there's insufficient evidence to set an RDA, an AI value, or adequate intake value, is established instead. We generally see this in childhood populations where there's not a lot of research done. Now we're going to use this graph to visualize the RDA. The RDA is based on the average needs of a population. Now, you may recall seeing a normal curve or distribution in a math or statistics class, and the RDA is based off of the concept of a normal distribution. In this image on the x-axis, we're going to put the requirement for a nutrient. This nutrient could be vitamin C, or thiamine, or calcium, or zinc, and we have the numbers or the values. And on this graph, we're going from 20 to 90. Depending on the nutrient, it could be 2 to 5, or 800 to 1500. So that would change based on the nutrient. On the x-axis, we see the percent of the population who meet their needs with a particular amount of the nutrient that's listed on the y-axis. So for example, if we look at the number 35, only about 2% of the population can meet their needs by consuming 35 units of this nutrient. That means that like 98% of the population would need more. This wouldn't be enough. If we look at the number 55, that's right in the middle. That means that about half the population can meet their needs by consuming 55 units of this nutrient, but the other half need more. This number right here in the middle is actually called the EAR, or the Estimated Average Requirement. And it just means half need more, half need less. It's right in the middle. It is the average. Now, we want everyone to get enough of the nutrients to maintain health, and that's where the RDA value comes in. So the RDA is set to meet most of the population's needs within a safe range. And we set it way up here on what is called 2 standard deviations above the mean in the normal distribution. So the RDA amount meets the needs of about 98% of the population for a nutrient. And so in this example, the RDA would be set at 80 units. Now, the RDA values reflect intakes to be achieved on average over time, meaning you might have one day, more on one day and less on another day, but the average over time you would meet the RDA. And the values are set high enough to ensure that the body stores will meet nutrient needs if you have a little period of inadequate intake. The RDA also reflects optimal intake, not the minimum needed to prevent deficiency diseases. And RDA amounts are within the safety range, meaning they're not too high. Now, the next DR we are going to discuss is called the UL, or the upper limit. And this is just the amount that defines the upper limit or of safety for nutrient intake. So intakes above this number could potentially be hazardous. Our next number in the category in our DRI, or our Dietary Reference Intakes, is the EER, or Estimated Energy Requirements. And this is the amount of calories needed to maintain a healthy weight. Closely related to the EER is Acceptable Macronutrient Distribution Range, or the AMDR. And the AMDR tells you what percentage of your calories should come from carbohydrate, protein, and fat. Now let's review everything that makes up the DRI, or the Dietary Reference Intakes. So first, the DRI is an umbrella term for different categories of values that describe how much of a nutrient someone should consume. And these recommendations apply to healthy persons only, and they are amounts that are needed for help and are safe. Then the categories in our DRIs are our RDA and AIs. These are what tell us the recommended intake for each day. The UL, or upper limit, which gives us, the upper limit for a nutrient intake for safety. The EER, or estimated energy requirements, that tell us how many calories are needed to maintain a healthy weight. And the AMDR, or acceptable macronutrient distribution range, that tells us what percent of our calories should come from the macronutrients, carbohydrates, proteins, and fats.